All right, ladies and gentlemen, in section 5.5, we are looking here at an equation that's called an exponential equation. The reason it's called exponential is because we're solving for the missing exponent. One of the first lines of defense for solving an exponential equation is try to get matching bases on either side. Well, in this case, 4, I'm going to leave alone, and the reason I can is 64 on this side can be rewritten as 4 to the third, okay? 4 to this power is equal to 4 to this power. Now, the only way this can happen, all right, 4 to a power equal 4 to a power, the only way this can possibly happen is if the powers are equal. Part of the thought behind that is 4 to the x power is an exponential function, but it's also 1 to 1. So basically what that means is if the answers are equal, the inputs are equal. Okay? But a simple way to say it is, basically at this point you ignore the bases. To proceed with the problem, you ignore the bases and you simply equate the powers, divide by 2, and we get the answer 3/2. And we do not have to check answers for exponential equations because with an exponential equation the domain is going to be the set of all real numbers, so if we did the problem right, whatever answer we got is going to be correct. So we're done with that first one. Now, this example, 2 to the x equals 30, cannot be done the same way, and the reason, 30 cannot be written as a power of 2. Now, sometimes my students will say 30 is 2 times 15, which is true, but that doesn't really do me any good. It's got to be an exponent, 2 to a power, and there's no way to do that here. So, in class, this is when I taught you. Okay, here's what I said. Basically, the cat is trapped up the tree, okay? And we need to get it down. How are we going to get the cat down? We're going to use a ladder. We have a choice of 2 ladders. We either have a log ladder or we have a natural log ladder. All right? I'm going to use the natural log ladder just because I want to. The natural log of 2 to the x is equal to the natural log of 30. And basically the rationale behind this step, if 2 numbers are equal, when I put each of them into the same function, I'm going to get equal answers. Okay? So I took the natural log of the left-hand side, I took the natural log of the right-hand side. I know they're going to be equal because the 2 numbers were equal to start with, so their outputs from the natural log function will also be equal. Now we're going to apply the power law of logs, which means this x rides down the slide, whee, boom, and it comes in front. X times the natural log of 2 equals the natural log of 30, and we finish by dividing both sides by the natural log of 2. So I have x is equal to the natural log of 30 divided by the natural log of 2. And if I were asked to approximate the answer to the nearest, thousandth or whatever, I would simply at this point take my calculator and just punch in natural log of 30 divided by natural log of 2 and hit enter. Okay? On the final exam, I want you to just pay attention to the directions. If it doesn't say to approximate, it's perfectly fine to stop here. If it says approximate, then you go further by, mashing your buttons, and then give the answer to whatever degree of accuracy they want. And we're done.